Okay, we are going to solve uh, 6 number problem from Pendle Booster round 7. Okay, row and product. This is a number theory problem. You can also solve it by using a data structure, segment tree, sparse table, or any range query. Okay, we need to first understand the problem statement. So basically, there is a story. Once upon a time, there is a young man. Basically, that was my love story. So if you guys want to read it, then okay, no problem. Okay, as in a negative is film, there are an integer and a positive integer x. For each query, you need to determine there is a subarray between integer L and R, whose products are divisible by x. Okay, so you are given an array and an integer x. So in each query, you need to tell whether this range exists, which product is divisible by x. For example, in fastest case, 3 to 4, 3 to 4, their products all possible subarray product 2, 7, 14, and x is 4, but there is no subarray which is divisible by x, right? Accordingly, if we go with second query, L to R, L equal to 2 and R equal to 3, 2 to 3, all possible, 6 to 12. So yes, there is a subarray which is divisible by 4, is 12. So if it is divisible by x, then print yes, otherwise no. And range n and q to t to the power 5, and okay. Let's see an array 2, 4, 3, 6, and a positive integer x equal to 12. Is there any if query say L equal to 2 and R equal to 4? Yes, there is a exists subarray which is divisible by 12. 4 into 3. In bootstrap approach, we can solve it manually. For example, in each query given L equal to 1 and R equal to whatever, we can check if there is a exist product which x is divided x modulo is 0, then we can say there is a subarray possible which is divisible by x, right? But in bootstrap approach, roughly it take per query n. So if it take each query n, then total complexity q into n. Q equal 10 to the power 5 and n equal to 10 to the power 5, right? So total complexity 10 to the power 10, which gives us really. So we cannot solve in this way. So we need to modify. A number is divisible by x if they share same prime numbers, right? 6 is divisible by 30. Sorry, 30 is divisible by 6. 2 into their prime number and two, 3, 5. why 30 is divisible by 6? Because they have shared uh, divisor prime numbers, right? If we see another example, 18 is something like 9. 18 is divisible by 9. If we divide it, uh, 9, right? So they have shared common prime number, right? So in this way, we can optimize our problem. Let's say x equal to 30, right? So what is the prime factor of x? 2 into 3 into 5. So 2 1 times, 3 1 times, and 5 1 times, right? The frequency of x prime factors, 2 1 times, 3 1 times, and 5 1 times. So uh, this prime factor we need to use when we arrange the given array. Other prime factor, we don't need to focus on other prime factor. This prime factor, if available in this particular array or particular range, then we can say x is divisible by x or not, right? Let's see an array 4, 15, 14, 15, 9, and 60, and their prime factor 4 equal to 2, 2, and 15 equal to. So, like, we just need to arrange this array, this prime factor. If we just consider this x prime factor, we don't need to any other prime factor. Okay, so how many times 2 occurs in first index? If we split 4, then we can see clearly 2 times, right? How many times 3? 0 times. How many times 5? 0 times. Similarly, how many times 2 occurs in the second index? 1 times. How many times 3? 0 times. And 5 0 times, right? But we don't need to consider 7. We don't need it. Just we need check 2, 3, and 5. This prime factor. Similarly, 15. If we split 15 into prime factor, right? 3 into 3 1 times and 5 1 times, right? And 4 9 3 into 3. That means 3 2 times and 5 0 times and 2 0 times. If we split 60, then 2 into 2 into 3, that means 2 2 times and 3 1 times and 5 1 times. 2 2 times, 1 1 times. Let's say 1 2 3, this range is divisible by x or not. So we need to just calculate how many times 2 occurs, 3 occurs, and 5 occurs in this range. So 2 occurs 3 times, 0 occurs 1 times, and 5 occurs 1 times, right? Which is of course greater than or equal initial x prime factors. X is initial prime factor 2 is 1 times, 3 is 1 times, and 5 is. So here 2 3 times, 3 1 times, and 5 1 times. That means x is divisible this range 1 2 3, right? Let's see if this x is divisible by 3 or 4. So how many times 2 occurs? 0 times, right? How many times 2 occurs? 0 times, this range. This range 0 times. How many times 3? 3 times. And 5 1 times. But we need 2 occurs 2 prime factor at least 1 times. But here is 0. That's why 3 to 4, this range is not divisible by x. Okay. We can calculate it by a prefix array and then check how many times occurs individual prime factor in this given range. If it maintains this range at least 2 1 times, 3 1 times, and 5 1 times, then it is divisible. This given range is divisible by x. Otherwise, no. So, what is the complexity of this code? So, in per query, max q per query, total query q, and maximum distinct prime. Maximum distinct prime factor, maximum distinct prime factor of x, because we don't need to check errors prime factor. We just calculate it according to x, maximum distinct prime factor of x. So q into, in rough case, a maximum distinct prime factor of x, it will be 14, which is more efficient than brute force approach. So let's jump into the code right here. So number of test case and QLX. Okay. Int nx sin x and vector error. So first we need to calculate prime factor of x. Map in prime factor of x. That's square. It's a plus plus y. So let's see. Yes, pi plus plus, and it's divided by I. Okay. If still x is greater than 1, that means this x is a prime number. So just according to this prime factor, we need to use in array. Vector map into initially 0 for it is for autos. Okay. Sorry, I is equal to y. Sorry, y ai is identical first equal to 0. Then p bid dot fast stick to b. We need to predict sum, right? So we need to calculate it last index sum. First first. So it dot fist added at first plus plus and AI divided first. Okay, this way we can calculate it now. And q, and then same q, query in left, right, c in left, right. Initially set okay, that means true for auto I, and we need to check if access this range and current sum b right I to first right fist first. Okay, and current is, for these frequencies must be greater than or equal x prime factor I second. I to segment, this is the frequency of this prime factor. See, okay. So just we need to run it. we have already generated input test case. Yeah. Uh, let's check it. Start it. No, yes, yes. No, yes, yes. Okay. Just we need to submit it. What's mhm. Yes, accepted. This is all for today. I hope you enjoy.